The way we have developed this architecture is when we are moving from raw to enrich to business, right? We are creating the intermediate table in DBFS file system as well, right? And that table, then we are loading into the, let's say I create some intermediate table in DBFS file system. Then in enrich layer notebook, I am reading that tables, right? And then that table I'm loading into the enrich layer file, right? S3 bucket. Then what I am doing intermediately when I'm running the code in the business layer, I'm again creating some intermediate table and loading data into the S3 bucket. So this table, the entire above part that what you are seeing, it's an intermediate table that I have created while doing my data processing. But at the end, I'm loading all the data into the S3 bucket. So that's how yesterday we create this end-to-end architecture. Let me show you one enhanced diagram, this one only. So this is what guys we covered end-to-end yesterday, right? I will go through few more points over here as well before starting Azure part. Guys, yesterday you remember we went through all this thing and we loaded data into the business layer. But when two parts remain, I think we cover, but I think maybe I can give 5-10 minutes more on these two things. One is Athena part, one is sending data from the Kinesis. This is Kinesis file data host, right? So currently I have loaded some file in SC, right? If you see in my based on our yesterday's discussion, if I go to my S3 bucket, smart mobility data, I have loaded some in raw layer. I have this file I have loaded, for example, CSV and all, right? But tomorrow, let's say guys, rather than loading, there might be some upstream system, right? Which can push data to my basically this bucket, right? Let's say tomorrow business requirement come and they want to send a few more files into my AWS 3 bucket. So how to do that, right? So for that, we have the another solution that is Kinesis firehose. So let me explain you these two things one by one. So the very first thing, how to query this data which is in S3 bucket via Athena. So I'm on AWS console. Okay. Let me go to the Athena here. I am on this AWS Athena console. Now, if you see, let me click this one, launch notebook editor. So I have just created, let me click on this and let me just click on a start session. So all the data, all the files which are available over S3 bucket, we can query via Athena. Sorry, we can query via Athena. So you see this sample notebook. The moment you click on a notebook, Amazon Athena, the by default notebook would get open, right? So what I'm doing now over here, guys, the files that I have loaded S3, in S3 bucket yesterday, right? I'm writing the simple Spark command, spark.read.format delta, right? And load my S3 bucket name, folder name, and this is subfolder name within that one, right? So if I run this command, it should show me all the data which is available in this particular bucket. So I'm just rerunning it. Okay. You can just see that, okay, it's a business layer incident heat map, right? So let it get complete first. Okay, it's completed, right? So you see all the delta records, we can see the incident, basically the analysis that business wanted to do, right? Basically based on a location, how is the severity, right? And how much are the incident count. So all these things we are getting from this data set, which is loaded in Amazon S3. If I just go to the smart mobility data, this is a bucket, right? Business layer, business, and heat map, right? This business layer incident heat map. In this, I have all the delta files. These are delta files, right? So all these delta file I am reading via Amazon Athena, right? And then further, a business team can use it or other team can use it for their own purpose. So in your end-to-end architecture, similarly, I have 3 buckets, right? I can also read another one bucket, like I create this data frame, business layer vehicle feedback summary, right? Spark.read.format delta and giving the location of this particular file, my bucket name, folder, and business layer vehicle feedback summary. This one, business layer vehicle feedback summary, right? All the files which are over here, I can read via Athena. Let me rerun this one as well. So it started. Yeah, I think yeah, this we run, not the third one. Business layer vehicle feedback summary. So see, it's completed with 100% and we got this result. Basically on which route, what is the current location, average rating, and the vehicle counts, right? So basically we can analyze from this data that how many vehicle counts we have from particular road, okay, on particular route ID, how much vehicle count are giving me this much of rating, right? So that's how I can analyze, okay, there is must be something wrong in this route. That's why people are giving the low rating and all. So basically what I'm trying to say, all the files which are available in Amazon S3, right? Your business layer, you can query via Amazon Athena, right? And then your team can further use it for their own purpose. Now guys, if you see about this overall architecture, in raw layer, we have the CSV files, right? But in delta architecture, we covered the delta, basically delta file system in earlier sessions, right? In delta file system, your enrich layer and business layer contain all the delta tables, okay? And that's how the delta architecture is we are talking about. So that let's say tomorrow, if why we are creating this delta architecture, let's say tomorrow I explain, right? Delta file system give you asset compliance, right? It support the transaction management, it support the asset, it support the upsert operation. Guys, with the help of normal CSV or Parquet file, if you not create, let's say, delta file system, it would be difficult to observe the record, or if it will be difficult to manage the transaction. Let's say you are reading, let's say, let's imagine for some time, this is not the delta lake architecture. Let's say you read a thousands record from this CSV, and now you need to update into this bucket, right? You cannot do upsert operation even with the help of bricks and all, right? With the help of Parquet file system. You need to do at a data frame level and then only overwrite, right? That's not the very good solution, I would say. Better way, wouldn't it be nice the way we are doing in SQL, right? Update all the statement if they are matching with some based on some key, and if there is no match, insert. So that sort of operation is possible with the help of these delta tables, and that make things more easier for us when we are doing this middle when we are implementing this middle in architecture. So that's the main benefit of delta lake architecture, guys. Few more things, right? I adopt this okay. Replacement. Now guys, see, we use the databricks as one of the solution, but you can easily replace that with the EMR or even AWS glue. It's a design decision, okay, but whether you use EMR, AWS glue, or databricks, anything, your main thing is Apache Spark. So you should have the mastery in Apache Spark. That's what I would encourage you, right? To get into to understand this overall flow and all, right? So Spark, knowing the Spark programming is the main thing, and these tools like Databricks, Glue, EMR, these are just tools. They all understand the Spark programming language, and you just need to write your code into the Spark. That's what we did in earlier sessions. So if you remember, we developed this data ingestion layer, right? In the raw layer, we have, let's say, data ingestion, while let's say S3, we create some, let it get open. So in the raw layer, we were trying to connect to S3 bucket with the help of some access key and secret key. Though in ideal cases, we can use other secure mechanism, right, to store this key in some other place and read the data from S3. But just for this demo, I am using simple access key and secret key. You can even use a secret utils and all, right? So that's other thing. But yeah, important thing is you can read data from these files and then just do show. You will be implementing in your actual project things like this. Okay, you are reading data from the files and you are getting the save as a table. So that's how I create this table in my Databricks, basically DBFS system. That's what I was saying, right? The intermediately I created tables, right? And that table I have use over here as well. If I need to, let's say in this layer, I need to join the table that I created in raw layer. I can do that, right? Uh, so I read data from the S3. I create a table in my raw with the help of, let's say, raw underscore and name table name, right? And then at a in this layer notebook, I am using that raw underscore table name. Maybe there might be 5 4 tables. And then I join those table and that result, then I'm loading into the enrich layer. That's what we did yesterday, right? So let's say this is the S3 bucket. See here, I created some of the table, a raw layer, traffic incident, then raw layer, feedback and all, right? If I go to the, and then streaming data as well, right? The way we read data from the S3, we even read data from the Kafka source also yesterday, right? So this is what the Kafka source, and then we went through all these things detail. I will not repeat this part because we need to cover Azure things also today. Then in data enrichment, we read, let's say, let's take this notebook, right? And then we will see here, we are reading data from the raw layer, right? And that, and then we are joining and all, and then this enriched data, finally, if you see, I am writing. So see, from this enriched layer, this enriched scheduled diap, from this enriched scheduled diap, I am creating table in enriched layer. And this table, if you see, this table look like this, and this table only, what I am doing, spark.read.table, incident impact diap, and that table I am writing into my enriched layer. So same thing I am doing in prod as well. Sorry, in a business layer as well. So what I'm doing, I'm creating intermediate table in, let's say, business layer, right? I'm reading the table in enrich layer which I have created and loading that as a file in S3 bucket, right? So one final thing in AWS architecture, AWS solution, let's say guys, Kinesis I just wanted to cover, right? So though we covered the from the solution, so these are, see, this and this one are the same diagram. It's just an enhanced version, a neat and clean version. But this is what we have. This is what we have used while doing things end to end yesterday. So maybe I will not. Yeah, let use this one only, and let me add Athena. Yeah, this is Amazon Athena only. So this is how we are reading data from the Amazon Athena. I showed you that one part, that part as well. Very final thing, guys. Kinesis stream. So guys, the way we are reading data from the Kafka streaming, right? Similarly, AWS also offer the Kinesis stream. That stream can send data to your S3 bucket, right? That's what we call the upstream system. So let me quickly show you one thing for that. So I am onto the Kinesis data firehose. Okay. Let me quickly tell that what is this. See, it's a self-explanatory. If you just go to this particular thing, see, Amazon data firehose. It's a real-time streaming delivery for any data. You can have any data, CSV, JSON, Parquet, whatever, right? At any scale, at a low cost. That's what they are saying, right? And then the way it works, see, it ingests data, transform. If you want to transform, you can transform even it, and it send to your respective location. It could be S3 or anything. So what we will do, we'll be doing, guys, we'll be just creating the simple firehose today. Kinesis stream firehose. So main purpose of this firehose, guys, Kinesis firehose, the way it's a streaming source. Though we covered the Confluent, but I just wanted to show you AWS flavor of streaming services. So see, it show the source has a multiple option. I will be using direct put. I will tell why I'm using direct put. Okay. And then destination is S3 bucket. Okay. Okay. Kinesis just is the name I'm giving. Okay. Now, guys, let me do one thing. First of all, let me create one bucket in S3 layer. Now, guys, let's say business come up, there is requirement, right? And they want us to create a new bucket, for example. Streaming source V0. Let's say this bucket name I'm creating and just giving all the things as it is. Let's see if this bucket name is available. Yeah, it's available and its streaming source V0 is created. Okay. I will go to my firehose. Okay. And use destination as I use destination as S3. See, I don't want it to transform, but the data that you are giving into the Kinesis stream, you can even transform it. So I will not go into that detailed turn on the transformation. So you can, what you can do, the data that you are getting in the Kinesis stream, you can use AWS Lambda to process row by row, but we will not do doing these things. So just wanted to see, let these things be as it is, unchecked. And now let me refresh these things. So we got, so this is the bucket name we have created, right? I just choose that. And then other thing, I don't want any line delimiter or dynamic partition. All these things I am just ignoring. And then only thing this over here in advanced setting. Okay. Let me see advanced buffer. Okay. Yeah, this buffer hint, right? See the way it works, you will be sending data from your source to Kinesis firehose. Okay. So if I just explain diagrammatically quickly, so this Kinesis I am explaining. Okay. So in Kinesis, there would be one source. Okay. Source is, let's say, this one only. Okay. This source will be sending data to Kinesis firehose. And this firehose then will load data into the S3. That's what we are doing in this architecture, these quick things. Okay. I'm just explaining one big architecture into small one, right? But how I want, once data, let's say, come up, when upstreaming system, let's say one record, I don't want every one record you to hit to S3 bucket, right? Let's say if S3 record send the 5 MB of data or some 10 minutes of data, then only send to the S3. That's what I'm doing over here, guys. If you go into my S3, this solution, yeah, here, right? So buffer size. I don't want the buffer size to be 5 MB, 1 MB is enough for me, and I will just give you here 20 seconds because I'm just demoing thing. I don't want it to wait too much just for this purpose. So the moment let's say moment 20 second complete, the smallest value of this one, right? Either 1 MB or 20 second. The moment 20 second complete, whatever data I have pushed to the this firehose, it will load into that S3 bucket. Okay, and then file extension, right? Dot CSV. I'm just wanted to load data in the form of CSV. So let other thing be as it is, and let me just create the firehose. I have created it in Oregon region, which is West 2, right? Okay, sometime we see this error. Let me click once again. So I have created this firehose. Its creation in progress. Let me guys quickly go to my PyCharm ID. What I will be doing, Oregon West 2, right? And let me share my PyCharm ID. Kinesis data generator. So as you can see my ID, right? Here it's a very simple Python code. Okay, I already have access key and secret key to connect to the firehose, right? And my firehose is also in US West region. The simple this array of record I am passing to the firehose, right? With the help of this access key and secret key and region name. What is my region name? It's a US West only, right? So now guys, let me run this, and then it's a simple thing. Each record, I'm just writing that record to client record.put to the Kinesis stream. And then this Kinesis stream will accept all this record and will send to the S3. So let me run it, guys. Now I have run my upstream system. Imagine this is my upstream system. Okay. Okay, I got. See, we not give the right name of stream, right? So that's what I give now. Let me rerun now. See, it load all the data, right? Then now, and if you see it even encrypted all these records, the record ID, it encrypted and all, right? All data it will encrypt and load to the firehose. Now, let me go to the S3 bucket. If you click on S3 bucket, streaming source, you see, I got some record. Okay. And it stored data in the partition format. So that's why you are seeing this hierarchy. And you see all the data that you pass, you are getting here as a S3 bucket, right? You can download and of course read it. That's the same thing. But in architecture, from architecture perspective, what I'm trying to say, that's what I just show you today as well. There would be one upstream system in this case, I am sending data from my ID to Kinesis firehose, and what Kinesis firehose do, it would send data to the raw layer. So in raw layer now we are getting data from different services, right? The Glue API call, Databricks, Confluent, Kafka, firehose system, which is getting data from some other system. There could be some on-prem system sending data to the firehose, and all this data I am getting at a raw layer, and I'm building this end-to-end architecture. Very final thing in Databricks things, sorry, in AWS architecture, guys. See, yesterday we create all these solution, right? Different layers I created. But do you think in production I will go, when I go to the production, I will go and just run this one by one, right? Run all and sell by, not right. We need some automated mechanism. Of course, schedule here we can do, but there is one better way, right? So in Databricks, we have jobs. Okay. You can easily create any job. Okay. Let me show you. So before that, let me show you a little existing job that I have created yesterday. So demo job I have created, guys, right? So here, if you see the task, okay, do you see, guys, all the things that I have created notebook, right? SC data ingestion, streaming data ingestion, then enriched layer incident impact, enriched layer. All this notebook which I have created, I have added here as a task activity, and they would run one after another. Only after first would get finished, that's how they would run, and they would, and then we will get the data at a S3 bucket. Finally, all the data at a S3 bucket in business layer, and this you can schedule via scheduler as well, right? You can schedule this to run. Let's say I want my end-to-end transformation, end-to-end execution from staging data to loading into the business layer. I want this to do via some job. So this is how I can do. I will be doing it, guys, in prod. I will be using some scheduler mechanism, and how I want. Do I want to run in every 1 day, right? Our whatever the frequency you want, or even you can run cron expression every, basically, if you click on a cron expression every minutes, all these things are possible, right? So that's completely possible. Let me, this job I have created yesterday, but let me create one quick job just to show you how simple it is to create any job. So let me give task name S3 data ingestion, for example, right? And then let me give job. Let me just rename this job. Okay, just a second. Fine. S3 data, I will maybe rename later. S3 data ingestion, right? Notebook is a node type, is a notebook, right? Because I have created a multiple notebook in workspace, and then guys, I will use this work notebook, one of the notebook. Let's say data ingestion, raw layer, and S3 data ingestion. Now what? Now let's say, and then here, guys, you have option to create the cluster. You already existing cluster. You remember multiple time we get the cluster. You can attach your cluster over here, right? Currently my cluster is not running state, but I just explaining. You can attach your cluster, right? And then if any library you wanted to install, that's all these things is completely possible. If no library, you can just create a task. Okay. So this task would get created. Now, guys, I will add another task. Notebook. Okay. Then streaming data ingestion. Here also type is notebook workspace. I will select my another notebook because I want first my stage data from ST should get load, and then data from my streaming or Kafka should get load, right? And then compute type is serverless or a cluster you can use, right? Cluster is something that you need to create a cluster, right? And depend on, see, depend on means this job would get run only if first would get success, right? Because ST data ingestion is a first job. So it's depend on this one. If this failed, this job won't get triggered. And then let's create a task for this one as well. Okay, so this is how, guys, you can now I created these things, right? You can further go and then add all the notebook that you have one after another, and that's what I have created in this. Let me show you, right? So let's say I'm just giving name our product job over here, right? And then I can schedule it via schedule trigger, add trigger, and all the things I explained, right? The schedule, simple, advanced. You can even do an at a file arrivals or continuous, right? For example, guys, there might be some requirement that you might wanted to continuously run that job, right? So if you just click on a schedule, okay. So see, continuous is task dependency are not allowed, all these things, right? See, why it's complaining us, I will tell. Because it's just streaming job is not should not be dependent on any other job, right? It should be continuously streaming to someone, right? So that's why it's complaining. So for example, this I will show in 1 second. So this is how, guys, you will be creating the jobs in your production, right? I just creating for data staging, but if you go at a job, this is my the other job that I have created, right? The demo job, all these things, right? Starting from staging, streaming data, then enrich layer, right? Let me minimize this. Okay, enrich layer, then enrich layer, enrich layer incident impact, live feedback, live vehicle feedback. All these jobs are running one after another, and they would run if only, let's say, first would get succeed, then only this would get start. If this would get succeed, then only this would get start. So that's how the dependency would happen. If anyone get failed, the next job wouldn't get start. So that's how these things are will be running. You will be running in your production, right? And I told you, with the help of schedule, you can schedule based on your requirement. The one thing that we just seen, that let me create a job for that one as well. So let's say I will create another job, create job, streaming data. Okay. Notebook, workspace, select the notebook. I have data ingestion, raw layer, streaming data ingestion, confirm, right? And then I will just let the things other be as it is. I will just create the task, right? So this streaming data ingestion, guys. Now let me click on add schedule, continuous. I had not got that error this time. If let's say, imagine, guys, if you have some streaming data source which is which you need to run 24/7, right? For example, Kafka messages. Confluent Kafka is sending, let's say, message every 1 or 2 minutes, right? And for that, your database cluster should be up and running 24/7. It should be streaming that data. So that's what the continuous job is. And continuous job should be single alone, right? Which should be reading data from those Confluent Kafka topic, right? This topic, Confluent Kafka basically, and this notebook, this streaming data would load data into this raw layer. This is 24/7 streaming job. So that's how you will be getting job in Azure data, sorry, this Databricks, AWS Databricks, right? So this entire architecture is composed of AWS plus Databricks solution, AWS Glue, Athena, right? S3, AWS Kinesis, Lambda API gateway, all these things we have used over here. Okay, guys, I think that's enough. We talk about AWS architecture now. Let's quickly move to our S3, our Azure based solution. So, guys, the solution that we implemented yesterday, same sort of solution we'll be implementing in Azure. Okay. Okay. Just a second. Just a wait, guys. Three. Yeah. Let me open this diagram. I think just give me a few seconds. Okay, anyway, let me share once again. So the solution that we implemented yesterday, right? The same solution we'll be implementing via in Azure, okay? Azure Data Lake. Basically, it's a data lake we are making, okay? And then instead of S3, we'll be loading data into the Gen 2 account, okay? Raw layer and all. Okay. Of course, in Azure, we'll be not using, it's a synapse, okay? In Azure, we'll be not using Athena and all. It's a knowledge pool. I will explain all these things, right? So that's the only changes in this overall architecture, guys. Okay, let me remove this part. This is not needed over here. Okay. So this is how, guys, solution. The same solution which we implemented yesterday in our entire AWS stack, we'll be implementing today this end-to-end solution. Okay. Wherein we will be reading data from these external sources like Kafka, right? From API, I will be keeping as it is. Imagine, guys, I have API hosted on AWS Lambda, and that API I wanted to call via my Synapse notebook. Okay, that notebook would call that API and would load data into the raw layer. So my Synapse notebook is calling Confident Kafka, loading into the raw layer. Similarly, this one, let me delete this one. Yeah. Similarly, this other notebook is calling API endpoint and loading data into the raw layer. And then this one, there is some system, external system, guys, imagine, which is loading data into the event hub. So I will be explaining all these things, event hub and all. Let me make it as a 20, right? Event hub, right? So I will be telling what is this event hub and all. So this is how, guys, our end-to-end architecture would look like. So all the system will send data to this ingestion layer, right? My ingestion layer basically calling data from the Confident Kafka from API, right? These are the pull-based mechanism. I am pulling data from these two systems, okay? From Confident Kafka and API. Whereas this system would push data to my event hub. And then event hub would load data into the raw layer. Synapse notebook would load data into raw layer. This notebook also would load data into raw layer. So if I just talk about the arrow wise, this arrow should be, let me see if I can reverse this arrow. To back. To front. Okay, no, I think let me do it manually rather than spending time over here. Yeah. So guys, this is a pull-based mechanism. I am pulling data from the Confident Kafka via this notebook and loading it to the raw layer, right? And then here also the same thing. I will be reading data from the API source. Okay. That arrow doesn't matter, but I just wanted to explain. Okay, that I am reading data via this Synapse endpoint. Okay, sorry, this API endpoint, and will load data into the my. Let me just correct it. Yeah, and we'll load data into the my AWS raw layer, right? Now, once I have data in raw layer, then I have other Synapse notebook which should be which will be processing that data and move data into the enriched layer. Then similarly, once I have data in this layer, I have some other notebook, Synapse notebook, okay, Synapse pipeline, which will be reading data from the enriched layer and load data into the Synapse data warehouse. Okay, so let's implement this architecture, guys. So first of all, for that, we need to get a Synapse book. Okay, so let me go to the portal.azure.com. Okay, I'm going to the Synapse. So before that, guys, see in this particular, before going to the Synapse one, I just wanted to show I have created one Gen 2 data lake. Okay, it's a data lake in the way we have having data lake in S3. Here I have Gen 2 data lake. Okay, storage account basically, and I have few folders: feedback, incident, route, and schedule. Okay, you see, I have loaded some data over here, raw CSV. Any incident, I don't have anything. Okay, because that's the API call which will be loading data into the incident folder. Then I have route CSV, right, and I have schedule CSV, raw schedule. So all this data I have. Now, guys, let me start creating a Synapse workspace. I can maybe, okay, I'm just opening another tab. Okay, let me create the Synapse Analytics workspace. Okay. So demo project is the workspace resource group I am creating. Okay. And then is, let's say, manage resource group. I have a name. Okay, that's fine. It's a resource group creation. I'm going to the Azure Synapse Analytics and creating the Synapse workspace now. Okay. I'll just give the name as a, what is my, this one, smart mobile data workspace. Okay, workspace. So that's the name I am giving over here to my Synapse workspace name. Okay, account name. So guys, whenever you are creating the Synapse, right, you need to basically Synapse workspace, you need to create the uh, one storage account. So that's what I am giving over here. So I will be just giving data lake v. Okay, data lake proj, just a lake I am creating, and here I am giving test is the my file system. Okay, basically guys, this account name and file system are required whenever you are creating the Synapse workspace, because by default Synapse workspace need one Gen 2 account. Okay, that's what we are creating over here. Okay, that's what we are creating over here and here, right? And this is my workspace name. Okay, let's go to the next part. I will be just creating the password. In earlier session also, guys, we create the Synapse workspace, basically authentication mode, right? How you will be connecting to your database, and this is username and this is a password I have here, right? And let other thing be as it is. I don't want other mechanism, other things over here. Networking, let it be as it is. I don't want a virtual network and all. Let me go to the next. Let this Synapse workspace get create. It's a paper you basically the amount you use, that's what you need to pay for. Paper use, right? Let me click on a create. So this would take some time. Okay. So meanwhile, this get loaded, guys. It would take maybe few. Okay. Since I know that in this process, I will be also needing Confluent Kafka as well. So that's what I will do. I will be creating the Confluent Kafka cluster as well. Okay. So that we should have the things ready at least. So my Confluent Kafka cluster. Okay. Environment, default. I just click on a create cluster. Okay. I will be using some basic server. Okay. And I will just create the launch cluster. This is, guys, the Confluent Kafka cluster I have created, right? Now let me create the API keys for this one as well, because to connect to the Confluent Kafka, we need to create the API keys. Okay. Let me create the API keys, create keys, my account. Next, these are the keys that I have. Let me just copy these keys somewhere so that I can have it handy. This is a key name. This is a secret. Okay. So let me just save it somewhere. Let me stop sharing for a second. Okay. Now I I store the keys basically at my system. Now guys, since we are following this thing since while creating the Kafka cluster and all, we all know that if you are creating the cluster, we also need some topic as well, right? Let me share my screen once again. So I'm in my Kafka cluster once again, Confident Kafka, and I'll be creating one topic. The name of the topic would be, guys, let me just write the name of the topic. So vehicle topic is the name of the topic that I will be giving. Create topic. All these things, guys, we discuss in detail, right? Topic, partitions, parallelism, and all, right? In earlier lecture. So topic, create with the defaults. Okay, let me skip these things. So at least my cluster is now ready. Before doing anything, let me see if my resource, okay, it's still in progress. I think it should get finished in some time. So generally it because it's a Synapse cluster, it takes some time to complete and all. So just wait for some time. Let it refresh. Let me refresh it. So now guys, the way we'll be doing, what we'll be doing. So we are getting this Synapse notebook, right? So here now, I will be ingesting data from these sources, API endpoint. I will show the API endpoint on all, right? So you remember yesterday, if I talk about this AWS Lambda and API endpoint, if you went through our yesterday session, right? If I just go to the AWS Lambda, if I go to the AWS Lambda, you see I created this Lambda yesterday. Let me click on this one. Yesterday only we created it, right? This is the Lambda I have created, simple function. Okay, you can see, you can easily replace with some microservice and all, right? But it's a simple Lambda, right? Why you need some cluster for that? So that's why we create a simple Lambda for this one, right? And if you just see the code of this one, this Lambda, it's returning you some incident. Okay, the API incident, basically incident response. If you see the code, it's a very simple that it's returning some array of incident. Okay, incident ID, location, severity, and timestamp. Then again, similarly, if you see incident ID, location, severity, and timestamp, right? So that's what this Lambda is returning. But in actual, maybe in your project, what you will be doing, this Lambda might be calling some database, right? This Lambda might be calling some database and will read data. This Lambda would read data from this database and then exposing that API. So I just told that, okay, I create this Lambda, but how this we are exposing my API, right? So Lambda is just returning this response. So what I did, I created API gateway yesterday. If you click on API gateway, the moment, let's say, you see this line, yesterday we created it, right? So the moment you click on this API gateway, you see you got all this data, incident ID, location, severity, and timestamp. Then again, incident ID, location, severity, and timestamp. So all this data you are getting as an array. Now, what we'll be doing in our solution, we'll be calling this API endpoint Confident Kafka, right, to load data into the raw layer. So let me see, meanwhile, if my deployment completed. Okay, good. Our deployment completed. Let me go to the cluster, smart mobility. Okay, this is a smart mobility workspace we have created. Okay. So it's again smart mobility data workspace. Okay, don't take it as a AWS. It's a workspace. Okay, just it's a naming that doesn't matter, but just to tell you. Now, guys, what I will be doing, I'm importing some notebook over here. Okay, let me first pause for a few seconds, stop sharing for a few seconds, and let me import those notebook. Okay, let me share my screen. Just a second. Okay. So as you see my screen, I have just imported this notebook. Okay. It's a data ingestion notebook, data enrichment notebook, and business layer transformation notebook. All these three notebook I have imported. Let me do few changes, guys, over here, because this notebook I will be explaining you line by line. But before that, let me make some changes over here. So you see the storage account which I have created, right? It's with the name of what is my storage account? Basically Gen2 account is smart mobility data, right? Let me copy this name. I will be explaining all this thing to you. Let me replace all, okay? Because I have data with this naming convention. Let me see in init layer I have setting. Yes, in init layer also I have. H. Find this one and replace with the storage account that I have created. I will explain this code line by line, guys, but just don't worry. But before that, this some changes are important to do. And then business layer, let me see. Ideally, okay, business layer also we have. Replace with this one. Smart mobility data demo, right? Replace all. Okay. So I have made these changes. Let me publish all. Okay. Meanwhile, guys, let me, because I know that I will be needing the Spark session as well. So what I will do, I will create a Spark session, Spark pool as well before starting explaining these things code and all. So let me go to the Apache Spark pool, right? Create a new Spark pool with memory optimize, and I will be using small pool. Okay, if required, we can increase later. But this is what the cost you need to bear for that, right? Memory optimize and review and create. Let me click on a create. So meanwhile, guys, this get create. Let go to the our Synapse notebook. Okay. So if you see, I have multiple basically notebooks in our code. Okay. Data ingestion, data enrichment, and data business and transformation. Right. All these things I have. So let me just take a marker. Yep. So the links, this, let's go code. Okay, it's good that our pool also ready. Let me connect to the Spark pool. Now guys, let me explain this line code, all these things code by code. Okay. So first of all, what I'm doing, I need to ingest data from multiple sources, right? And where I need to load that data into my raw S3 bucket, smart mobility data. This is my bucket name, right? Smart mobility data. So for that, what I'm doing, I am creating, this is a recommended way from the Azure to connect to the any storage account with the help of link service. This piece of code you can find in Azure document as well, right? So here, what I am doing, first of all, I'm giving my bucket full name, okay? Then spark.config.set, okay? My bucket full name path and link service name. So guys, we need to create this link service. So let's go on manage section, okay? Link service. Let's create one new link service where I wanted to connect to this data lake, right? Gen2 data lake. I'll be just using this name with the help of account key I wanted to connect. I'm just clicking my subscription storage account which I want to connect to, right? I want to connect to smart mobility data, and let me click on a test connection. So it succeed, right? And let me create it. Okay, it created successfully. Let me anyway publish these changes, and let me go to data ingestion notebook once again. So what I'm doing over here, guys, see, I give the storage account name to which I want to connect to. Then I create the link service name, right? This is a secure way. See here now, I have not added any username, password, key or value, right? That is a more secure way to connect to the storage account. And then these are the just few things that you need to give the configuration to connect to the storage account. That is Hadoop configuration, and then storage account name and value is SAS, right? And then similarly, same Hadoop configuration, storage account name and value as a link service based SAS provider. So because we are using link service based mechanism. And then simply I am reading the data which is available in my smart mobility routes in the raw layer. Okay. So if you go smart mobility, not AWS, sorry, smart mobility container routes and raw routes CSV. Smart mobility. Okay. So I think smart mobility. Let me see if naming some smart mobility, and then raw is a container. Okay, I think yeah, we made one. Let me correct this, guys. This should be the container name. Okay, let me create a raw as a container. First of all, over here we can create it, no problem. A raw as a container. Okay, this is what I will be creating the container now. And in raw, let me create. Can I move this folder from here to there? Okay, I don't think there is an option. Anyway, let me create a raw. Okay, and then in the raw folder, I'll be creating. Just a second. Yeah. Raw and routes, right? In the raw folder, raw container, I am creating another folder with the name of routes. Okay. Similarly, I know that all these folders shouldn't be in the top layer. Let me just copy these names somewhere. Feedback, incident, right? And then schedules. Anyway, let me delete these other things, routes, incident, right? Let me delete all this container. So I just need a raw layer container in higher hierarchy, basically upper hierarchy. Yep. So I have created this raw container. Okay. In the raw container, guys, I have routes basically, then feedback. These are the folder just I am creating, incident, and then schedule. Let me upload some files over here, guys. Okay. So let me stop for a second. I will quickly upload all the files and then I can show you. Raw feedback I have uploaded. Routes I will be uploading now. I will be showing 1 second my screen. Raw routes. Finally, schedule. Okay, let me present my screen once again. Yeah. So if you see my container now, guys, as you see my container, I have raw as a container, and in raw container, I have multiple basically files. The feedback in which I have raw feedback, then incident is blank because that what I will call my API, and load file into incident folder, routes, right? In routes, I have the raw route, and the schedule, I have raw schedule. So all these files are available over here. Now, guys, what I will do, I have connected to my Spark session, right? And I told that this entire code is just to connect to this storage account via some link service. Now, in this container is storage account. In this container, raw container, I wanted to read data from the routes. Okay, let's run this. This would take some time. So let's wait for this one. So imagine, guys, while it's running, imagine, guys, in your solution, sorry, this is Synapse notebook to call this API, and this is another notebook which will be calling API endpoint. Okay. What happened? That thing got drive. Something weird thing I'm seeing in drive. Anyway, let me just, yeah. Let me save this, guys. I think it's making some, save this. Yeah. So this was the diagram actually I was looking, but yeah, I don't know, due to some reason it went. So nothing, it's the same only. So in Synapse notebook at an ingestion layer, data ingestion layer, I will be connecting to the API endpoint, will load data to the raw layer, right? will load data into the raw layer. I will be connecting my Synapse notebook to the content Kafka, will load data into the raw layer. And similarly, there will be some another system which will be loading data into the event hub. And that data I will be also loading into the raw layer. So that's how we'll be doing now, guys, one by one. So Spark is still in running state. While it's running, guys, I can just show you this other code, right? So call API hosted by serverless function. So you remember earlier I in the API endpoint I have told, right? This endpoint API endpoint lambda API response. This was from REST API. For example, this one, right? I can use this endpoint configure over here, right? So this API endpoint I am calling, okay? This API endpoint I am calling, getting this data, okay? And then after getting what I'm first of all, I'm getting this API endpoint and then request.get API URL. I'm getting this data. From this data, I am creating the data frame, pandas data frame. Then once data frame got created, I'm converting into the Spark one, okay? Because to store into because Spark is more powerful, right? And okay, currently we have less data in your API, but let's imagine your API is giving the huge data. Then Spark is a better way. So that's why I'm converting into the Spark data frame. Then since I wanted to load this file as a single CSV into my this raw container and incident folder, guys, that's directly I cannot do. What I'm doing, first of all, I am creating one temporary path over here. Okay, temporary location, and then I am doing df.coalesce. Coalesce is a guys function in data frame to reduce the partition. So the way we do data frame dot repartition, right, to increase the partitions of your, let's say, data frame, increase or decrease. But coalesce is ideally used to reduce the partitions. Why I am giving one? Because I just wanted to create a one file. Then I am writing this file with the header true into my temp folder path. Okay. So coalesce to one file and write to temp folder. Now the in temp folder, guys, I will be getting multiple files because that's how this API would work, right? It will give maybe data when you are running the Spark things, right? You will be getting data into the distributed things, distributed files, right? So all this temp file path, okay, I'm just listing those file path, okay, and I'm saying part hyphen, okay, if any file start with the part hyphen, take then just take that and then final path I'm creating as a this particular raw traffic incident.csv. So what I'm doing over here in this line, I'm getting all files. So but this piece of code will create multiple part files, okay? And then this particular piece of code will create a multiple part files. Then I am getting all these part files, okay, in the form of array, okay? And then finally I am loading that, combine that entire data as a final file over here with the help of MS Spark util file move, file path, and final file path. Okay. So entire files I am moving as a single files. So hope you got. So this line will be having multiple part file. I am moving this all the part file as a single file with the help of this line. So this is how I am doing, guys. And then after I am done with that, I am just removing this my temporary path I have created. So that's the one of the way I'm doing. So this job got succeeded, guys, right? Meanwhile, let me go to the raw layer. Okay, df.read. Okay, I just read the df.read. I can even show you df.show, right? So this is how my routes table would look like. Once this get finished, we can get that data. So since I use less memory, it might take some time, but yeah, it should, because it's in a running state, it show jobs are running, and let's wait for some time. Meanwhile, guys, this load in incident, I haven't loaded any file, right? How I will be loading data into the incident? With the help of this API call. My Synapse notebook will call this API, which I just show, and will load data into the raw layer in incident folder. See, we just loaded this data. Currently, I not loaded with the header, but I'll leave it. Okay. But this is how the data would look like, right? I have route ID, route name, origin, destination, and kilometer. All the data I have. Okay. So with the help of, this is just to confirm, with the help of link service, I can connect to my storage account. Now, guys, let me click on, let me run second part. Okay. Call API hosted by serverless function. So the what are the API that hosted by AWS Lambda, we are calling that and creating the single file out of it and loading into the incident table. I just explained this code as well. It's showing it's in running state. Just a second, guys. Yeah. So while this run, so see guys, this show it's run. It's showing the status as a true. If you see, let me refresh this incident. You see, we got a single file with a raw traffic incident. So our this part is completed, right? With the help of API, we call REST endpoint and loaded data into the S3 bucket. Okay, now let's move to the another things. Now guys, call Confident Kafka streaming data source. So here, let me just make one minor change. Let me see that file name, vehicle stream. I don't want to replace it. I just wanted to search it. Okay, let me just see the vehicle. Yeah, vehicle stream. I had multiple place. Control H, vehicle stream. Let me see, because why I'm doing this thing changes, guys. I don't want the tab file to be get created with vehicle underscore string underscore stream basically. So I see here vehicle underscore stream. Okay, let me replace this vehicle underscore stream with vehicle stream. Replace all. Okay, fine. Now, guys, I just make some minor change because I will why basically I will tell. Okay, in some time. So, guys, Confident Kafka streaming data source. So, right now, guys, we connected to API endpoint and load data into the bucket. Similarly, we will be connected to the Kafka endpoint as well. So, for that, I have already created the keys, right? Let me copy those keys over here. And guys, this Confident Kafka, I think so. We anyway going now since multiple session, we are going through this particular code. This is username. This is the password. And this is username and this is password. Okay. And let me see here. I need to do. Okay, that's fine. So let me quickly explain this code, guys. Right. So we are connected to the Confident Kafka topic, right? So first of all, I create one schema for that. My schema look is a struct type. Okay, I created a schema like this, and then I'm reading data from the Kafka Spark.read stream. This is what my Bootstrap server is. If I just copy my this URL and would go to the my cluster setting, you would see the same Bootstrap server I'm connecting to, right? So I'm connecting to this Kafka server with the help of key and password just I give, right? And I would get a Kafka data frame. Now from this Kafka data frame, guys, I am just doing select expression because we already also talked that Kafka will only have the key and value. So what I am taking from here, I am taking value as a string. Okay. Basically, I am casting that particular value as a string. Okay. And then casting as a JSON str. Okay. So first of all, key and value, I told, right, Kafka store data in the form of key and value. So whatever the value that I'm getting, I'm taking it as a string and then casting that as a JSON str as a column, right? Now what I'm doing, I'm using form JSON function on that particular column, right? And this is just schema that I am giving. So whatever I'm applying form JSON function on value, right? Value that I am getting from the Kafka, and I am casting that as a this schema, right? Vehicle ID, route ID, current, and all these things. And then I'm just doing alias that as a data and select star from data. That's what I'm doing, guys. So let me run. So before running, right, let me send some messages to my Kafka topic. So I have created the Kafka topic. Let me show my ID, right? Kafka vehicle stream. Okay. Is the same code that yesterday also we sent use, right, guys, to send to the Confluent Kafka. So I'm having this configuration to connect to my Confluent Kafka, and then I'm passing this array of vehicle to the with the help of producer.produce topic name, and key is a vehicle ID and entire value. You are getting, right, guys, this entire value I am passing as a message into the Kafka. So what happening? Your entire value would come as it is, this entire value, whatever you have, right? For example, this entire value would come as a value in your, let me go to notebook. You'll be getting this entire value as it is over here, right? And then this value, you are converting as a string. Okay, whatever the value that you are getting, you are converting that as a string, right? And creating the column as a as JSON. So this value and that value is the same, right? You are converting that as a basically as a string and then creating the column like JSON str. Then on that column you are applying form JSON function, right? JSON str, this particular column, and then you are asking this with the help of this particular piece of line. What you are doing, you are asking to convert this entire JSON str schema in this format. So that's what we are doing over here, right? So now let me run my vehicle stream code. Okay, and I have topic already created. Currently, if you see, let me start vehicle stream. Okay, it's sending data as you see. Let me go to the Confluent Kafka cluster. If you go to the topics, click on a topic. Currently your topic is empty, but you should see some message on over here. Let me refresh. So it's showing loading some messages. So you see all the message that we sent, we got over here. Now what I will do, guys, I will be reading that messages from here. Let me run this piece of code. It show it's completed, right? Just now. And then I will be loading that into my data lake. Okay. In smart mobility, in this basically output folder. So what I'm doing, I just given the output folder location. Remember, guys, whenever you are loading the Spark, basically streaming data source, vehicle data frame is a streaming data source. So you will always be needing checkpoint location. So checkpoint location is a temporary location, right? What I'm doing, I'm doing vehicle df dot write stream in the form of delta. Output mode is append, right? Checkpoint location I am giving and start. So let me run this, guys. So it say it completed. Let me go to the vehicle stream raw. See, we got the vehicle stream, and see, we got the file in the form of delta over here, right? Delta tables, delta logs and all, right? So this is how, guys, we connected to Confluent Kafka and load data into this output folder. I told that whenever you're reading the streaming data, you also need the checkpoint path as well, right? So this checkpoint path also I have here. So this checkpoint path is just for their own purpose, the streaming job purpose, that because it needs some temporary location to know what is being streamed and all, right? So that's what you need. You need to always give some checkpoint location, right? Now, guys, we loaded all this record. Let me just quickly show run. So now we have a routes table, right? Routes record. In routes, if you see, I have data like this. Currently, I am running it via notebook, and then I will be getting finally pipelines out of it. So each show is action. So it will take some time. Most of the time. So meanwhile, it get load. See, on we are reading data from the routes, vehicle stream, right? Vehicle stream is a delta file, right? We loaded, and then schedule, and then incident. All these files are looking like this, okay? And feedback as well. So in feedback, I have feedback ID. If I go from the start, in feedback, I have feedback ID from end. If I show you feedback, I have feedback ID, route, customer name, rating, customer comment, and all, right. Similarly, for incident, I have incident ID, location, severity, and timestamp. Then for schedule, I have schedule ID, route ID, departure time, arrival time, and day, right? So this is all the data that I am having. For vehicles team, I have vehicle ID, route ID. This is data that I receive from the Kafka endpoint, right? So this is what the data is. And then finally route, right? So I got the succeed message, right? And this is what the data look like in my routes table. Let me run vehicles team as well. I just wanted to ensure before going further, all the data is in, at least we have the all the data ready. So we'll be running this just to show you one by one. In vehicles team, see, that may be possible that in vehicles team you don't have any data. Why? Because it's stream data and you might miss some stream sources. So let me rerun once again. It is, yeah, it's showing running vehicle stream data. See, you see, we started getting some data. It's a stream data. See, a stream might come in some time, right? So now see, sometime before no data was here, but you see now all the stream data we got over here, right? From the in the form of data lake in the vehicle stream, right? And in vehicle stream also I will be having all the data files, right? So let me run this one as well, the schedule one. These are the CSV file that definitely would run, but the streaming data might come late, right? Some messages might get delay and all, right? So streaming job, you need to take care of maybe continuous stream. And if you are reading, let's say, same message once again, then you need to make sure that your code should have that logic to remove duplicates and all from that particular messages and all, right? Duplicate message you should be removing, right? That's what maybe that's how you'll be writing your code. So now let me run this one as well. So I got a schedule as well, and then incident as well, right? So all this I think I have got, guys. Let me just see. Yeah, two only remains. We at least we need to make sure our raw layer is good in term of data. We have the right data. Otherwise, unless until you have the things good at the raw layer, you cannot move to the enrich and business layer, right? So we are ensuring In the raw layer, I have route, incident, feedback, schedule, right? Multiple container coming from the API, Confluent, Kafka, right? All this should have right data. That's what we are ensuring. See, for incident also I have the right data. I have the incident ID, in which location that incident have been raised, severity, timestamp, right? Then route also the schedule ID, what is the route ID, departure time, and then arrival time, all these data I have, right? And then the final one, the feedback one. With this, we can at least imagine, okay, our staging layer is in good form. We are getting data from all our external system into our raw layer. Now, once you got the data into the raw layer, then we'll be running our data enrichment. Data enrichment is nothing but, guys, we are duplicating data. Meanwhile, this run, you see, we have some of the file here in CSV format, right? Sorry, not here. This one, sorry, mistake. So, sorry for the mistakes. Our files, some of the files are as a CSV over here, okay? CSV. So what we'll be doing, we'll be changing those CSV to delta when we are moving to the higher level, right? So some of the files are in CSV format over here, right? So in data enrichment, what I'll be doing, I'll be using this Synapse notebook to convert that as a delta. Plus, I will be also removing duplicate from the files. All this operation I will be doing in enrichment layer. Let me, okay, let me at least move this thing over here and let me focus. Yeah. This is what we'll be doing, guys, right? See, in feedback also, we got a nice data. So our data staging is completed now. Okay. Let's go to the data enrichment. So in data enrichment also, let me see first of all, Control H. Because I have created the container basically folder with the vehicle stream, not vehicle underscore stream. So that's why I'm replace all, right? So guys, we are done with the staging part. Let me stop the session for stop session over here. Okay. And yeah, because I am using only limited memory, that's why I'm stopping session. If I go at an enrich layer and use the same notebook, it would give me the message that, okay, you not have the enough memory or CPU core, whatever, right? So let me connect the Spark session, same Spark spool. Okay. Now, guys, I will quickly explain this enrich layer code. What I'm doing over here, see, I have smart mobility data lake. In that, I have raw folder. Plus, I will be getting now enrich folder here as well, right? Currently, I don't have enrich folder over here. Let me create the enrich layer, okay, with the name ENR. And since I know that, okay, let's wait for, I create the enrich layer, right? So what I'm doing, guys, I'm just giving this, first of all, business location, sorry, storage account, and giving the name of the folder, right? I'm giving this as an enrich base and raw base, just creating some variable, right? Then I know that in my raw layer, right, smart mobility data, I have routes, feedback, incident, vehicle, sorry, schedule, and vehicle stream. All these files are input paths are available. Similarly, in enrich the ENR, I'm just making, I wanted to make sure that I should have all this path. So I will be just running this. Okay. Meanwhile, it gets run. Let me explain other thing as well. So what I'm doing, guys, first of all, I'm reading all this data from the, if you see, route path. Okay. So if you see the raw layer, route path, feedback path, incident, schedule, vehicle path, from all this, I am just reading that data in the form of data frame. Okay. Basically raw layer. From the raw layer, as you see, I have multiple locations, right? This feedback, incident, route, schedule, and vehicle stream. I'm just reading that particular folder with the header true and with this path. What is this path is talking? Smart mobility data, raw and particular folder, and all the files within that particular folder, right? Once I read all these things, then what I'm doing from the all these data frame, I might have some duplicate. I'm just dropping those duplicate data. Okay. With the help of drop duplicate and just creating the new data frame out of it. Then finally, guys, store that as a delta files in data lake. Currently, all these files, whatever the files that you are seeing in the raw layer, let's say the incident CSV, right? It's a CSV format. Or let's say routes, it's in CSV format. Only the vehicles team I have in delta lake format, right? But all other are in CSV format. But what I want in my solution, I want all the files in enriched layer should be of delta lake. So that's what I am doing. I am converting each file in the form of delta. Okay. This even if I not give, that won't be issue, but let it be as it is. So I'm making sure all the file in my enrich layer, route enrich. See here, route enrich is nothing but all this you grade up, give this path, right? Enrich base, that is this storage account, this folder, right? And this entire basically this is storage account name and this is enrich is the container name, right? So I want all the data to get load here as a delta file format, right? Then finally, then again, I am reading this delta table from the enrich layer. Okay. So with the help of Spark dot, because in enrich layer, I loaded data as a in delta format, right? I loaded data as a, in the delta format. So I'm reading that all the files in as a data frame, right? And just showing over here, right? That's what I'm doing over here. So let me run. So this is complete. Let me run this piece of code as well. What happened? Okay, I got maybe what we need to do. Just wait. I will explain. 1 second. Okay, it's showing me this error. The reason for this one, guys, because we stop some session and all, right? That could cause this issue. What I can do, maybe I will create another link service to connect to the storage account. Let me see. It should sometime, because whenever we are stopping and starting session, we might see these sort of challenges. I did that for just because I have less memory. Smart mobility data raw, right? So this I already have over here, the session and all. No, nevertheless, what I will do, I will just get another link service over here. Lake chain 2, continue. Okay. Subscription, smart memory data, right? Test connection, create, and let me publish it. Okay. Meanwhile, this get published. Let me see. I think it's still in progress. Okay, show publish completed. Close. Let me see. Okay, let me give that particular name. One. Okay. Best thing would be, guys, what I can do, even if this not help, I can maybe stop that spark pool and will create the new one, because it's look like me that it's issue because of the spark pool that we stopped. Otherwise, I don't see any issue over here. Smart mobility data, right? Raw and enrich routes. Okay. Let me do that thing, guys. I will just maybe stop this session. The Spark pool. Guys, let me just delete it. And I'll be getting new one. Basically, I'm thinking that because of that Spark pool, we stopped in between. That's why it lose the configuration that we did in earlier sessions, and that's why we are getting this error. Let me pause it and then I will recreate so that in new session we can have the all the things available. It's in progress, I think. Failed to delete. Okay. Failed to delete because, guys, I'm thinking, let me, because our Spark session is in running state, let me first of all stop it. And it should not give this error. Link service name, because again, I'm thinking stopping and starting session again will may take some times and yes, I don't want. Let me stop and let me restart once again. Let's see if that helps. Otherwise, we can just quickly move through the code base and then I can create the pipelines just to explain you. Let me just clear this cell output. Okay, this output as well. So basically, guys, what I'm doing over here in my Sparks in enrichment layer, I define all the variables, right? And then all the variables, right? And then I'm reading data from the raw layer and loading, basically reading data from the raw layer, removing duplicates and storing into the enrich layer as a delta file format. That's what I'm doing with the help of this piece of code, right? And let me now rerun this one. So I started this thing. And maybe guys, in this post this lecture, I will even show you or give you commit all these things on the GitHub notebook so that you can go through code and all. So meanwhile it run, guys, I can even show you, right? So see, all this process would create some data into the enrich layer, right? And then we'll be having the business layer transformation as well, right? So what we are doing in business layer also, let me first replace this vehicle stream as a vehicle stream list all. Okay, it's fine. Okay, see guys, the moment I restarted this session, it worked, right? With the help of this link service. It should even work. Let me see if this work now. See, it even worked. So there was not issue with our entire thing. The only thing that we stopped the session. That's why we got this error. Now, guys, what I'm doing, I'll be running this piece of code. Okay. Then this piece of code is just a variable declaration. I am reading all the data frame. Okay. Okay. From the raw layer. These are all the raw layer path. Okay. I am reading all this data frame. And then dropping these duplicates. And then storing that as a delta lake in enrich layer. So this would take some time, but with this, our enrich layer should have all the delta tables. Okay, it show in progress. Because we are loading maybe almost 6 tables at a time. That's why it's taking more time with the help of less compute capacity that we have. And once, guys, we loaded this data in the form of delta, then in business layer, we are generating some more insight out of it. Okay. Once we see now in what I'm doing in business layer, I'm just reading data into the enrich layer folder, right? With the help of all this command. And then I'm just taking the average route rating from the feedback, right? So that how many, basically business wanted to generate some insight out of this data, right? So in business layer, maybe I will just run 1 or 2 command and just to show you that how this entire data would look like. Just wait while this get to finish. So now guys, what we are here now in this solution, right? All our basically files we are storing as a delta file format in the enrich layer. And from the business layer notebook, I will be reading this enrich layer delta file, doing some groups and join and loading data into the business layer finally. Okay. So let me show you that one. Okay, look like job execution is still in progress, so it will take maybe some more time. If I just go to the raw layer and then let's say raw, the enrich, we got this table got created. It's still running, right? Let's say if I go to the feedback layer, you see the delta file. All the tables are should be of delta. Whereas in the raw, you had only CSV and only one file format of the delta, right? But in enrich layer, I want each and every file should be of delta. So that's what our process is doing now. It's loading all the data in the form of delta layer, delta table. So guys, once this get finished, maybe it may take some more time. So rather than waiting, what we can do, so it will load all the data into the delta format into the enrich layer. Now what I'm doing, I'm reading this data with the help of this delta location. I'm reading the spark.data format delta and the path of the delta file format. Once I read all these file format, what I'm doing, I'm just taking the average route ratings, right? So feedback data frame that I have got feedback data frame. And then I'm just applying with column right? And then group by route ID, aggregate. I'm applying group by on route ID, and then I'm applying aggregation on the rating plus order by average rating. So that's how I can get on which route I am getting how much rating. Similarly, and then I'm writing that result as a delta file in business layer. Okay. So this is how my, if you see in, I don't have currently business layer, but I will go and maybe create one business layer solution as well. Sorry, container as well. So what this piece of code would do, it would read this data, average rating, and we'd load this average rating as a average route rating folder in business layer location. Similarly, okay, and just reading that data from that business location, that particular location, then top congested location. Here I'm doing, right, guys, the incident data frame I have received, right? Here, if you see, I got this incident data frame. That incident data frame which I have got, I'm just doing group by location and then doing some aggregation, aggregate count, right? So on a location group by, I'm just getting the count of incident, right? And order by incident count. So this how I can see on which location I am getting most incident raised from the basically a passenger. This could help me to understand, okay, I may need to, our authority may need to do some better optimization in these roads, right? Similarly, and then once I got this particular congestion DF, I'm loading that congestion DF as a delta lake in my business layer. Okay. So for each and every route wise travel time, right? This also I'm applying the joins on enrich layer data frame. And right, this is my enrich layer data frame, right? Schedule DF, right? And then this schedule DF, I'm just applying some logic over here, right? SQL logic. I want which route take longest time to travel, right? So all this data I'm storing here, right? I just showing over here, and then that data I'm loading into the business layer in the form of route travel time. So all these things I'm doing, guys, in my business layer. So if you see, finally my enrich layer got succeeded, guys. See, if you see, and now I got all the files in my enrich layer, and all should be with the delta file format, right? Starting from vehicle feedback, everyone should be of delta file format, right? Vehicle and all, right? So I got all these data set. Now finally, guys, let's move to business layer. I can just show you maybe one of the transformation in business layer, because we just created the business layer. So before that, I think I need to stop this session. Let me stop this session and let me just copy it and let me go to the business layer. Session stopped. Let me connect to this Spark pool over here, right? And let me first of all paste these things. What this is required, guys, to, because I'm stopping session in between. That's why we need this thing. Otherwise, in general scenario, we don't need to stop and start in every time. But just since I'm explaining this U code line by line, and we have limited memory, that's why I'm doing over here. So let wait this also to get finished. So what we are doing over here, the same, guys. I am connecting to smart mobility data with the pub link service that I have created earlier, Azure Data Lake Storage. Right here, this is a more secure way to connect to data lake. Though I am connecting to the raw layer, but that's fine. In business layer, I'm just this is a test code I'm writing over here. Otherwise, in normal scenario, you will be not running this each and every time, because since I'm stopping and starting session, that's why with the help of limited memory that I have, that's why I'm doing these things. So now, guys, we are now at a business layer transformations. It show session is ready. it ideally should start. Otherwise, maybe we need to stop and start once again. So now at a business layer, I'm having some notebook, Synapse notebook, which will be reading data from init layer and load data into the S3, load data into the Gen 2 of business layer in the form of delta. That's what we'll be doing now. Okay, it's in progress. See, it started, right? With the help of same link service. I created Azure Data Lake Storage 1 as well, but that's not required actually. We can go with the only one. Okay, it succeeded. Let me read all the enrich layer. See, this is my base path pointing to the enrich layer tables, and just I'm reading the routes, feedback, all the table in the form of delta. I'm just reading this one. Once I read this, guys, what I will do, I will possibly just load one or two table, right? Maybe just one table for sample, and then I will show you how to get that table in actual real world. Maybe you can have the multiple table in business layer, right? 50, 20 tables, right? But in our case, I'll be loading just so now see, I got all the enrich layer data frame over here, right? All these data are enrich layer. Now on this enrich layer data, this enrich layer data is not duplicated, it's in delta format. And on that, I am applying, let's say, I wanted to get average route rating from the feedback. Okay, let me run this, guys. Instead of even show method, doing show method, what I will do, I will average rating.df. I will be just running it. Okay. And then in output path, right? This, okay. I think let me control H. This is our location is different one. So let me just control H and control V. Replace all. So you see, yeah. So we are good till over here because we were anyway pointing to our this smart mobility data only. So I loaded all the data frame. Okay. Now command executed. Now guys, I even will run this one on this feedback data frame, which I have received over here, right? Feedback data frame. I'm just applying some aggregation, and then that data I'm loading into the smart mobility data business layer as a average route rating. So if you go over here in business layer, currently I don't have any table. Let me create this one. So it's in progress. Guys, the way I am creating this one table, you can create all this table, right? I can give the notebook to you guys as well to just show the, it's just Spark SQL Spark command that I have written over here and creating the multiple tables in basically business layer, right? Route, travel time and all. But I will just show for one table as example, otherwise it will take more time, right? So you see it succeeded. Now if you go to the business layer, refresh, see you got the average rating routes as well over here. Now guys, see, we are creating this notebook one by one over here, right? Let me even publish these things. But in production, you will be not writing this loading data into the business layer one by one, right? So what you will be doing, you'll be creating some pipelines. We can quickly create some pipelines. Let me create one pipeline. Okay. This notebook, okay. Let's say raw layer. I'm just giving just name over here. Settings, notebook name. See, data ingestion is a layer that I wanted to connect to, right? Spark is a pool. Minimum executor, let's say I give the 2 and maximum executor I give the 4. Okay, for example. These are the executor settings that I need to give, and driver size is small. Okay, authentication, all these things, let it be as it is. Okay, now I want first of all raw layer should happen first. Then I want enrich layer happen next? Then after success of this one, I will be calling enrich layer data frame, right? So if I go to the settings, data enrichment notebook, I will be calling, right? Spark pool, minimum executor 2, maximum 4, driver size small, right? So this is how, guys, driver size, okay, small, right? Yeah. So this is how, guys, you will be creating the second notebook in your case. And the third notebook, business layer. The very last thing, okay, this is how you will be connected to the business layer. Similarly, in business layer, you will be pointing to the business layer transformation, right? You will be giving the spark pool. The executor size is small one, minimum executor 2, maximum 4, for example, right? And this entire pipeline will be running as a job. We'll be creating the trigger. Let's say I will be creating just new trigger, and I may want this to run, let's say, every 1 hour, right? I can give it to schedule option, right? And I want it to run on every 1 hour, for example. In India location, okay, it should start running maybe from tomorrow, for example. I want it to run, not today, let's say, it will run on every 1 hour, right? So this is how, guys, you will be creating the actual job in production.